can I request everyone who's participating to come forward, and we can have a more interactive session. Bring out your laptops because we'll be doing some real life, well, exercises. So especially for those hackers that are hacking on Kyber, this could be very useful for you. Just wondering, does everyone know what Kyber is about and what it does? So I don't know if I need to cover like what Kyber does. Yeah, does everyone know like what Kyber is about? Okay, then maybe I can just head straight into the workshop. Or do you guys want to go one round of, talking about Kyber? Workshop? Workshop? Okay. No more slides then. Okay, so to get started, right, for those of you who have laptops, go to this GitHub repository. It's github.com/kybernetwork/workshop. And so the basic activity that we'll be doing today is to set up the whole Kyber network in your local laptop, right, through a Ganache snapshot. So we're going to be doing trades, swaps in your local laptop. We're not having to use like Robston or Liquidity. So I'll leave you to cloning that, and I guess I'll just go on and then just show you like a quick demo of how it looks. Yeah. No, it's the same thing. So when I say swap and trade, it's exactly the same thing. Swap, trade, convert, exchange, okay? Yeah. All the same thing. So in this GitHub workshop, you will see some instructions as well on how to set it up, like install Truffle. You need the latest Truffle beta because we're using some latest syntax from Truffle to make things more user-friendly and to easily interact with some of the smart contract functions. You need to have Ganache installed as well from Truffle Framework. So if you have those set up, then we can move on. If not, I guess you can just follow along, and you can always visit this repository if you need to like go through it. Okay, so basically I have this already set up in my local machine. Over here, so the workshop repository. And like any Truffle workshop, there's a migrations folder over here. So this migrations folder is in charge of like migrating the whole Kyber network contracts into your Ganache snapshot. And in theory, you can do this as well in testnet or in mainnet, but this has been, so disclaimer, right, this has only been tested in Ganache. So I wouldn't recommend you like just using this in testnet, but you can. So there's also a config folder over here where you can configure like tokens. So basically, right, one of the configurations of setting up tokens is the exchange rates, right? But for the purpose of this demonstration, we'll just leave this as default values because we're just interested with doing swaps. But if you want to like put in your own token, like its own decimal place or whatever unique properties, then you can set it up over here. And for the contracts as well, we just use like some mock tokens for this example. Yeah, and all the smart Kyber network smart contracts are here as well. So let me go through a sample migration. Sorry. Cricket sounds. Okay. So there's actually an existing snapshot which is in DB over here. And if you don't want to be bothered to set up another snapshot, you can just use this. And the syntax for doing that is it's actually in the README as well. So there's the command there on how to actually run and use the snapshot or to migrate into a new snapshot. So what this arguments mean is that we're trying to we're creating by default 10 default Ether accounts that have been pre-funded with 500 Ether. And we're using a kind of like a preset mnemonic for this accounts. You can use your own mnemonic as well. And I guess the rest is self-explanatory when you use it yourself. But yeah, so let me just try to migrate into a new snapshot so you can actually see what happens when I'm migrating the entire Kyber network contracts into a Ganache snapshot. So let me just run this. And while I'm running this, I can open a new terminal, go to the workshop. Oops, sorry. Workshop. network development. So this has been set up already in the truffle config over here, the different networks. So basically we're running on, development over here. So this is basically pointing into our local Ganache snapshot. So let's do a migration, right? And this is basically how it would look like. And we'll let this just run. So you can see actually what's being called, what functions are being called. Can it be seen, by the way? Sorry. Yeah, there we go. Just let it compile for a bit. You can see that we're also compiling some example contracts that we'll be using as well. So yeah, here we go. So basically what's happening is that it's deploying some of the mock tokens, and then it's going to deploy some of the, or all of the Kyber smart contracts. And afterwards, it's going to set up some permissions, like we have an operator, we have an admin, we have an alerter, and then it's calling other functions to like list tokens, enable them for trading, setting the conversion rate, setting them like and other important functions. And afterwards, we're transferring some test tokens into the user account. And the last part is just showing a summary of the different contract addresses, the tokens that have been deployed, the different wallets, the different permission addresses, etc. Right? So basically, once you see this screen, then the entire Kyber network contract has been set up in your local machine, and you can do trades. And I'll show you what an example trade looks like. Okay. So there's another folder over here that would be of interest, where we have different examples. So we have Solidity, Truffle, and Web3 examples. Truffle is basically using the Truffle syntax because there are some artifacts that are by default already exposed to the environment. So you don't have to like import Web3 anymore. You don't have to import other artifacts. So we can look into the Truffle scripts just to take a look. This script is basically just getting rates, right? So we have different tokens that have been deployed. So we have like KNC. We have Omisigo, we have Decentraland Mana tokens that have been deployed. And the goal of this script is just to show the different conversion rates between Ether to KNC, KNC to Ether, and KNC to Omisigo, right? And if you don't know this, but we always use ETH as a base pair. So when you trade from ERC20 token to another ERC20 token, what happens is that it always goes from ERC20 to Ether and then Ether to ERC20. So so for the first thing that you'll see is the conversion rate between Ether to KNC. So let's just run the script and see the output. So exec, examples, truffle, get expected rate. Yeah. Okay, there we go. So one thing to note about get expected rate is it doesn't matter what the token decimals are for the token, like the source and destination token that you as an input. The output will always be in 18 decimal places. So, like for example here, right, ETH to KNC conversion rate would be 1 ETH would be equal to 549 KNC. By the way, this conversion rate has been inputted like many months before, so it might not be so accurate right now in CoinMarketCap, given the market. But yeah, just an example, right? Because this is part of like my config. And one thing you'll note is that there's an expected rate and the slippage rate over here. So just an brief explanation, right? So expected rate is basically the exact conversion rate of, let's say, Ether to KNC, right? But we always add a slippage rate. So slippage rate in this context is about 97% of the expected rate, or basically a 3% difference, right? And we always give the slippage rate as another input into a trade, because when the transaction is in flight, because it's an on-chain transaction, right? When the transaction is in flight, then maybe the rates could change, right? And if you want to ensure that your transaction gets executed despite like the market going down with the slippage rate, then it ensures that your transaction will execute. And you can, yes?
The intention of the slippage rate is to cover the potential movement before the transaction is made?
Yes.
So it covers like 20 seconds of risk?
Yes, pretty much. And you can actually put any kind of rate into the trade, right? So you can put like a much bigger slippage, right? In case of like very volatile markets, and you just want to ensure that the transaction will execute. And if, for example, you put a certain rate, and because the market moves and it goes beyond the expected rate that you put, then the transaction will basically fail.
So, if the rate falls below the slippage rate, the transaction is supposed to fail, right?
Yes, it will fail.
And here we are assuming that the liquidity providers are moving the prices because of the volatile market.
Yes.
Right? So, when they move the prices, those are also on-chain transactions, right?
Yes.
So, even those are anticipated to take equivalent amount of time.
Try again.
So, if the liquidity provider is sending transactions to change the prices, even those transactions would be taking time, right?
Yes.
Okay.
So actually, I'm not going to get into this, but we have actually different kinds of reserves. So the one thing that we're talking about is a manual reserve, where a reserve manager is feeding on-chain rates. So they have to do an on-chain transaction. But we have an automated reserve as well that adjusts the price based on the inventory of the token in Ether in the contract. So each trade that happens, then the price changes.
Okay.
Yeah. So we have, yeah.
Probably I should have stated the reason for my asking. So the way I understand it, Kyber is there to provide instant liquidity,
Yes.
but not to provide a price on your wish. You will get the price from the liquidity provider, right?
Yes.
So why am I giving an input expected rate? I should be getting the expected rate from Kyber, right?
Yes, so basically this is what happens, right? If, let's say, you have multiple reserves that's serving liquidity for one common token. Let's say 3 reserves are offering liquidity for DAI, right? So the Kyber network will basically iterate through all these reserves and just serve the best rate to the user. So let's say reserve 1 gives like 3 DAI for 1 ETH, reserve 2 gives 5 DAI, then always choose the 5 DAI reserve. Basically just the best rate.
So,
and that's what you get.
So is expected rate part of my transaction when I'm trading?
Yes. So in a nutshell, right, when you do a trade in Kyber, it's always 2 functions. One is getting the rates, and the second is doing the actual function code to trade. And I'll show that in a while. Okay. So this is getting the expected rate. In Kyber, we also offer like simple interfaces when you just want to simply swap between, let's say, Ether to token. So there's a function actually called swap Ether to token, and this is very simple. You just want to swap Ether to token. But this may not be so flexible, so we won't cover this as much. The most interesting use case, maybe for you developers, is the trade function. And this is basically how it works, right? So in this script, you can see that I'm actually getting the expected rate, or the conversion rate between KNC to Umisigo. And the third argument here is the amount of KNC that I want to swap. So first is the source token, second is the destination token, which is Umisigo. I want to swap into Umisigo. And the last is how much KNC I want to swap for. So that is get expected rate. Afterwards, once I get the rates, so I have both expected rate and the slippage rate, I can input that into the trade function. And this is where the actual swapping occurs. So the first argument is again the source token, because I'm trying to trade my KNC into Umisigo. So the second one is the amount of KNC. The third one is the destination token. The fourth one is also an interesting argument, is the destination address. So in here, I'm actually specifying a user wallet. But you can actually specify any address. You can specify another smart contract, another user's address. So for example, you can actually chain them, right? You can actually specify another external smart contract where if they receive this swapped token, right, then another kind of like a function call occurs. And that's when you can chain multiple function calls. And then the last one, this next one is called max destination account, destination amount. And what this basically means is that I want to only swap exactly, let's say 100 Umisigo tokens, right? So let's say one KNC is equal to 100 Umisigo, right? And I want to just exactly swap 100 Umisigo. So what if the user actually inputs 2, but I just want to get 100 Umisigo? Then by specifying this max destination amount, the rest of the KNC will be returned as change back to the user, because I only specified like exactly 100 Umisigo tokens to be exchanged. And for this amount, right, if you don't care about how much max destination that you want to swap for, you can just specify a very, very large amount. And the last one, the next one is the conversion rate. So we're using the expected rate in this case, but of course it's best to use like a slippage rate in case of market movements, like in mainnet. The last argument is a wallet ID, and this is specific for those projects that have joined our fee sharing program. So let's just say that you have an application, like a wallet, right? And you facilitate trades within your wallet that's using the Kyber protocol, right? You actually can get a share of this fees because the reserve pay fees in order to facilitate trades. You can actually get a portion of these fees as maybe kind of like a profit because this swap has been done in your platform or application. Yeah. And the last one is just for truffle, like you're specifying what wallet you're sending from. So let's see like what this looks like. So in this script run, I'm actually doing 2 trades. I'm doing a trade from KNC to Omisigo, and then from KNC to Mana. Yeah, that's it. And then just showing the different balances. So we run that, and then run trade. So first we show the initial balance of the wallet, and after the trade, this is the balance left. So I basically traded about 200 KNC for some Omisigo tokens, and for some, basically 100 KNC for Omisigo and 100 KNC for Mana, and this would be the equivalent. So if I run it again, then you can actually see this old balance and then the new balance after. And you can see this 2 transactions over here, so the KNC to Omisigo and KNC to Mana. So yeah, there we go. Yeah, so you can actually, from this, right, just using 2 functions, you can actually build really unique applications. Let's just say I want to build a splitter converter, right, which is one of the hackathon projects in San Francisco. And basically what he did was this. He wants users to be able to contribute to a smart contract, either or die, and then he can specify like what tokens he wants to split those either or die to. So for example, the user chooses like 3 tokens, right? Maybe like KNC, Omisigo, and Mana. So once 100 Ether is brought into the smart contract, it automatically splits equivalently, like 33% each, to the 3 different tokens. And this all happens in a single transaction. And that happens because you are able to chain multiple function calls in your smart contract. So this is for like the truffle examples. We have the same equivalent for Web3. You can find them over here as well. Of course, it's much messier in Web3 because not all artifacts are automatically exposed like in Truffle. But it's basically the same concept where as I run it, then it would do the same kind of trade, and you can actually see that. Just to show you, no trade, yeah, there we go. So yeah, again, just showing the balance and then executing the trade. So from the workshop, right, you can actually see code examples there that you can copy and then use in your own applications to be able to do trades. Now, the interesting part, the smart contract examples. So, sorry. So over here is a simple contract called trade, and I'm doing just one thing. I just want to execute a swap. So I'm taking in as an argument the source token, how much source tokens, a destination token, the destination address, and the max destination amount, right? And it's basically simple, very simple execution. So here I'm just checking that the user is able to transfer, like because we're trading ERC20 tokens, right? That the user has approved the transfer of tokens from his own wallet into the contract, and then afterwards. There's actually, I'm not sure if you guys are familiar with it, but there's actually a front-running attack possibility with ERC20, and we just implemented this here, so just as a precaution. But this is the most interesting part. We're just actually calling 2 functions again, which is get expected rate and then doing the trade, and that's it. That's your Kyber swap trade, right there. So from here, right, we can just basically call this except swap function, and then it calls this get expected rate, and then does the trade. So if you want to have multiple trades, then you can just multiply this twice. And let's say I want to do something like for the conversion rate, right? I want to put like a source quantity like divided by 2, which means I want half of this for this type of source token, and then the second one will be the same as well, like half of it will be another source token. Of course, you need to change the arguments here as well to add like 2 additional, or 2 basically source tokens here, and then you can specify the rest. And you can actually perform 2 trades in a single function call or a single transaction. So, any questions on that?
Is there a limit on the quantity being traded?
Okay, so Depending on the liquidity of the token, right, you might have trouble in the quantity, right? So, for example, if I want to trade, let's say, 1,000 worth of Ether for this token, right, then you might have trouble there because the reserve might not have enough liquidity to facilitate the trade. So, usually around, let's say, around 10 to 20 ETH would be safe, like for a single trade for a token. And it depends on the reserve's strategy to automatically rebalance their inventory when a trade happens. Okay.
So what I want to know is where that number comes from. Is it available in the contract? What is that max?
Yes, so because everything is on-chain, right, you can actually see that. So if you go to the mainnet Kyber network contract, you can actually see the list of reserves there. And from the list of reserves, there are some functions there where you can actually see like the amount of that inventory they have, the transactions that they facilitated, and how often like they do on-chain rate updates for the conversion rates. Yeah.
So either you are taking all this information, doing some calculations and showing one number on the front end,
yes,
or this number is available on the contract and you are just putting it.
Yes, exactly. So that's actually what's happening with our own Kyber Swap, which is our own in-house built application. So maybe I can just demo that a bit. So for those of you who are not aware, we have this application called Kyber Swap, which is leveraging our Kyber protocol. Over here, let me just unlock my MetaMask. So it's the same concept, right? Where, let's say I'm swapping from one token to the other, and then when I enter this, then it automatically gets a conversion rate. And what you actually see here is that it's doing a call, right, to get expected rate to get this conversion rate. So whenever I do like a change of the rate, then it will automatically query get expected rate. And then when I do a swap, it will just pass this get expected rate to the trade function. And here we can actually specify how much of slippage that we want. So if I click, oops, source not too high, 0.01. Okay, there we go. Here. Yeah, oh, sorry, it's over here. So here's the description of the min acceptable conversion rate, or basically what you enter for the slippage rate, right? So what we always recommend is always 97% of the conversion rate, or a 3% slippage. But you, as the user, can always adjust this value so that, you know, in volatile markets, you can ensure that despite the price going down, your execution of your trade will still occur. Yeah. And this is just basically being passed to the smart contract.
So, in the case where I request for more coins than Liquidity provider can provide, will the rate happen for the amount he can provide and the rest will be refunded?
Okay.
And that rate will be reverted?
Yes. So, one way to check, right, whether the trade can be facilitated is using get expected rate. So let's just say I specify a very large amount of tokens, right, for this trade, right? Because there's a part in the function where you specify how much tokens that you want to trade for the source token. Let's say I put a very big amount, right? If this trade cannot be facilitated by any reserve, then it will return a rate of 0. So 0 is just a way to check that whether a trade is possible or not. Or whether, for example, a reserve is down or the entire Kyber network is down, for example. Like maybe it's under maintenance or is being upgraded.
So we have to check iteratively what is the max by like putting out different quantities and then seeing when it's returning 0?
Yeah, I mean, like if you want to test like what's the maximum, right?
Yeah, we have to check iteratively, or is there some number which we can directly call?
No, there's no number. So because each reserve is managed by a third party, right? Yeah, each reserve managed by a third party, so there's no way to check unless, yeah, I mean, there's one way you can like do some data analytics and then just have a rough figure. We have somebody from our team that actually has done this, and maybe I can connect you to him, and he can give you the exact figures for this liquidity for the different tokens and reserves. So, for example, right, like DAI, right? DAI is very popular, and we actually integrated with Oasis Direct to get some additional liquidity there. So we can facilitate like large amounts of DAI in a single trade, because DAI is one of the most popular ones being traded. Yeah. But for less popular ones, then depends on your, you know, how much liquidity is being provided. Yeah. So any questions on the smart contract side? Is that all okay? Okay. Yes.
So after the trade, you specify the destination.
Yes. Okay, I can give you one demo. Has anyone here heard about ETHSingapore? Okay, one guy in there, and he's from Kyber. Good job. Always support. So ETHSingapore is basically Pokemon on the blockchain. And they created this unique game where each monster is represented by a non-fungible token, right? And in order to buy monsters, you need to pay either with their native token or with Ether. But by integrating Kyber, we expanded their token choices, right? And this integration actually has two parts. So first is a smart contract integration and a front-end part, which is a widget that we provide. And you can find this widget in our developer portal. So there's this section here called Widget. And I'll show you how it looks like. So if I go here to the store, which is official store over here, and I'm going to use one of my wallets that has money, which I don't know, testing. Sorry, let me just see, okay? Ah, crap. Maybe this one. Okay, never mind. Maybe I'll not do a real transaction. So let's just say I want to just buy the cheapest monster over here, as one of this rates should load depending on how fast the Wi-Fi is. Okay, never mind. Let's just skip that. Please, demo gods, please. Okay, I think the Wi-Fi is not participating. One more example is CoinGecko. Has anyone heard of CoinGecko? Thank you. Kyber guy again, over there. Yeah. So CoinGecko has integrated with Kyber to offer token swaps natively within their website for selected tokens that is supported in Kyber. So for example, Omisigo over here, there you have this button called buy and sell. And they have, of course, integrated the widget that we provide for the front end as well. So this is how it looks like. So let's just say I'm planning to buy some Omisigo. That's a bit too small. And here I can trade in like how much Ether I want to buy some Omisigo tokens. So we provide this front-end widget for you so that you don't have to worry about the UI. And we've abstracted as well the communication with the smart contract part. So you only have to worry about your UI or your business model, basically. And here we have a widget where, let's say I connect my MetaMask. I just connect. And then when I confirm, then the trade happens. But I'm not going to confirm because I don't have enough funds. Yeah. And ETHSingapore is still loading. So I can show you as well like the smart contract code we developed for ETHSingapore for this. Contracts. Right. Okay. So the story is like this, right? ETHSingapore has already launched their smart contract into mainnet, and they don't want to modify their own smart contract code to be able to integrate Kyber. So what we did instead is wrote a wrapper such that the user from the website will interact with the wrapper instead and then call the relevant functions to do the trade, and then call a function from ETHSingapore to be able to send the non-fungible token. So we can go through this line by line just to show you. Over here. So the first thing that they want to do is display the price of the monster in ETH. So this is what's being called by the UI to be able to show. Oh, okay, it's showing now, but this is uncachable. Sorry. Okay, let's wait. So they have this concept where you can buy or catch monsters. Here, finally. Okay, here. So before Kyber, they can only pay with ETH or the native token of ETHSingapore to be able to buy a monster. But by integrating Kyber, you can actually pay with any ERC20 token. So this is how it looks like. I can click this, and then I give my monster name. Okay, ETHSG, because we're in ETHSG. I agree, catch now. And then we go through the widget that they've integrated as well. And here I can choose the different tokens that's supported. Let's say KNC, Mana, etc. And as I click the different tokens, then it shows the conversion rate. So what happens basically here is that as I select a token, it just calls the getExpectedRate function, passing in the source and destination token. And because the destination token is Ether for them, then yeah, because we're paying in Ether in the end, right? So that's what happens. And you know, we go through the motions of like setting your wallet, connecting your wallet, etc. And this is basically what happens in the smart contract. So we're just calling a function to get the rate. And then afterwards, we can call a function called catch monster that passes in like the Kyber network contract address, the Ethermon address, the name of your monster, the number, the amount of tokens, the source token, etc. And if you look at the code, right, what happens is that we actually do a trade. We get the expected rate first, which is passed into this contract. There's a min rate over here. And then we do a trade first. That will swap basically the user's token, any token that he wants, let's say KNC, into Ether. And then once we have this Ether, we then call a function from Ethermon to catch the monster. And we pass in as well the user's address, such that when this executes, then it will immediately pass the non-fungible token or the monster back into the user. And this all happens in a single function call and in one single transaction.
So, I think this question is related to the things that happened.
Yes.
So, what I remember is we got 5.025.
Yes.
And what I think is, does that have to do with paying the gas cost using the token through address or something like that?
Yes. So the user only pays the gas costs.
But is it possible for an address that has no Ether but some extra tokens to even pay for the gas using the token through as well?
So right now we haven't implemented that, but that's actually an idea that we're exploring.
Is it possible
Maybe
based on Ethereum's functionality? Is it even possible?
Yes, it is possible. So have you heard of gas token? It's made by one of the researchers from Cornell, Phil Diane, where you can actually pay gas using this gas token. So if anyone has heard of that, then you can actually read up on that as well. Just gas.
Is this for Ethereum?
Yes, for Ethereum.
And with the assumption that I have no Ether in my
Yes,
wallet.
the assumption. You can actually use this token to pay for the gas instance.
Oh,
Yes.
so this is on your roadmap?
Yes. Yes. We actually, it's not a priority, but we might explore those, like maybe in the future. So it's called gas token.
So, okay, so
Yeah,
is this what happened in the drinks thing?
Sorry?
Is this what was done on the drinks thing? Like when we
Oh, no. So basically in the promo code, right, when we're sending you DAI, there's already some ETH in the wallet. That's why you're able to facilitate the transfer after swapping the DAI. Yeah. I hope you enjoyed that experience. Yeah. So this is the gas token that I was mentioning, where you can actually pay gas with this gas token instead. Yeah, so basically if you go to our developer website, you can actually see the other integrations that have been, that have been done by other projects, and how they actually leverage this simple two functions, right? Just getting expected rate and doing a trade. So you can do like financial applications that do on-chain fund rebalancing. You can do liquidation on-chain by being able to liquidate into like a specific token. You can build applications where you can do a payments use case, like Ethermon that I showed a while ago. Yeah. So there's a bunch of examples out there that have already integrated Kyber and leverage this. And you can explore all this documentation in our developer website, so developer.kyber.network, and we have all the guides here. I didn't cover the reserves part, but if you're interested in being a reserve, then we have a guide there as well. Let's say you're a token team and you want to provide liquidity for your token, then you can do that as well. And the widget part, right? So the one thing I can demonstrate right now is we have a widget that you can integrate in your front end, which you saw a while ago. We have what we call a widget generator. So this is what it looks like. Let me make that a bit bigger. Yeah, so we have different modes over here, and you can specify like the recipient address, which is like your own wallet, what kind of payment you want. Do you want it in ETH? Do you want it in DAI? And other parameters that you can specify here. And basically what happens is that you just get this pre-generated HTML code that you can paste into your website, and then there, you have integrated like a very basic payments use case for Kyber. And this is how it looks like, right? So this is the button that you integrate. Yeah, and this is the same thing that you've seen like with the Ethermon example. Yeah, that's like one of the features that we offer as well. Any questions?
So how to do it if the buyer is a smart contract?
If the buyer is a smart contract, it's still possible. So the smart contract, the buyer, right, just has to call the function from the other smart contract that calls the trade and the get expected rates. Yes. And this is what happens like with the different financial application integrations, like with Melonport, with SET, etc. I guess. Yeah.
So it's still possible.
Yes. So again, with the Ganache snapshot, you can explore this, especially for those hackers. Like you can explore like what kind of applications you can build using this. Because the entire Kyber network is deployed there, we can do. You can basically simulate what we have in testnet or in mainnet, the trades. Yeah. Any other questions? Okay, I guess that's all for my demo. If you need to know more, then you can look for me or the other guys that have the Kyber network t-shirt over there, like that dedicated guy over there. Yeah, and we do have bounties, so maybe I can explain a bit more on that. Kyber.net. So it's kyber.network/hack, and it will redirect you to our bounties page over here. And we have a couple that we can suggest that you can build. So we have also some co-bounties like with SET protocol as well, like to create an issuance relayer. Yeah, and the prices are there as well, and what kind of like judging criteria that we're looking for. So if you're interested in winning any of these bounties, make sure to visit our bounties page in GitHub, or you can do kyber.network/hack, and you can see all the details there. And again, if you need any help or if you have any questions, visit our booth. Any of us developers can help you in the duration of this hackathon. And if you're thirsty, we provide liquidity. Water bottles. Yeah. So I guess that's it. Yeah, that's it.